Hello everyone, in our previous video regarding Laplace transform, we discussed the basic formula of Laplace transform, we discussed the definition of Laplace transform for any factor that is a function of t. We discussed, not only we discussed but also we derived the Laplace of 1, Laplace of any constant, fundamental properties of Laplace, trigonometric functions Laplace and exponential function of Laplace. So in this particular video we are going to see the properties of Laplace, and regarding this we are going to see questions of this later on. So let's see and let's watch this video full. So Laplace of e raised to power at was 1 upon s minus a, as I discussed and derived in our previous video. So the thing is, if you multiply e raised to power at with the factor f of t, first condition is if Laplace of f of t, it is given as f bar of s. If it is Laplace of f of t, it is a function of s, you know, by using the Laplace I discussed in our previous video. So if it is the f bar of s, then if you multiply any exponential factor e raised to power at where a is any constant, so the f, it will be a function of s minus a. Okay, so this property is going to be called as first shifting property. First shifting property. That means if, like, what is f of t, let's say one example, f of t is sine to t. So it is in the format of sine of at. What is the Laplace of sine of at? That means Laplace of sine of at is a upon a square plus a square. We derived in our previous video. We derived also. So Laplace of sine of 2t. What is Laplace of sine of 2t? Laplace of sine of 2t is a upon a. What is a 2? So 2 upon a square plus 2 square, that is 4. So Laplace of e raised to power at. What is e raised to, let's say e raised to power 5t into sine of 2t. So it is a function of s, that is f bar of s. So it would be f bar of s minus a. S minus a. What is a? 5. So s minus 5. So you simply put s minus 5 in place of s. Right? So 2 upon s minus 5 whole square plus 4. So that is the example. Okay, I hope you understood this property very well. Now let's discuss the second one property. Okay, so you understood the first shifting property very well, I know. So according to first shifting property, Laplace of e raised to power at into f of t, that would be f bar of s minus a. How you can derive it? So Laplace of f of t would be, Laplace of e raised to power at f of t would be, firstly integral part. Laplace means the combination of three particular things. That means integral whose lower limit is 0, upper limit is infinity, e raised to power minus st into the factor, that particular factor that we are dealing with. The particular factor is this whole thing. So e raised to power at into f of t dt, right? So it means 0 to infinity e raised to power minus s minus a t into f of t dt. Okay, now Laplace of f of t, Laplace of f of t, what was Laplace of f of t? That was integral 0 to infinity e raised to power minus st f of t dt, and it was the function of f bar of s. Now in place of s, what is there? S minus a. So it will be a function of s minus a. So simply it will be f bar of s minus a. So it is the derivation of first shifting property. So it is the derivation. Now so derive over here. So I have shown you one example of this first shifting property. Now let's discuss one another property, that is Laplace of e raised to power 6t into let's say sine 5t. So that would be, what was Laplace of sine 5t? The Laplace of sine 5t was 5 by s square plus 5 square, that is 25. Now in place of s you will write s minus a, that means s minus 6. So that means Laplace it would be 5 by, that means it would be s, sorry, 5 by, in place of s you will write s minus 6 whole square plus 25. So it is the application of first shifting property. So in this property, if you learn this property, you don't require the whole calculation for this. Properties makes your calculation much more easier when you have to tackle with this type of questions, right? In the inverse Laplace transform, you will see the application of this particular property, like the first shifting property, that is Laplace of e raised to power at f of t would be f bar of s minus a, if Laplace of f of t would be f bar of s. So it is the first shifting property. I hope you understood this first shifting property very well. Thank you for watching this particular video. If you have any particular doubt regarding this, you can comment in the comment box, and I will provide in the description box the previous link of the video, that is the basic video of Laplace transform. You can check out that particular video also, because if you don't watch that particular video, no need to watch these videos, because these videos are based on the basic concept. If you don't clear your basic concept, then regarding upper steps will be very much difficult for you. Thank you watching for this video. If you like this video, then do like, share, comment in the description box. Like, thank you.